Hello. Today we're talking about section 1.2 functions, and we're going over problem number 3 and number 4. We talked about the function is where there's no repeated inputs. For every input, there's exactly one output. Can we look at this graphically? Yes, this is called the vertical line test. Because we don't want the input to have different outputs, we can draw a vertical line and see if it passes through the graph at more than one point. If it does, it's not a function. Let's look at this example. Draw a vertical line through any piece of this graph. Boom. I see an output value here and an output value there. There are two output values. Is this a function? No. Let's try this one. Draw a vertical line. Again, I see two output values for just this one input. Is this a function? No. What about the third graph? Continue to draw vertical lines, chopping up the function. Are there any places where there will be more than one output value for each specific input? No. That means this is a function. For every input, which represents those vertical lines, that's the input, there's only one output. What about this one? Draw the line. I just see one. What's happening here? Notice this is an open hole and this is an open hole. So if I drew a vertical line, it would only be true right there. Since this is open, it's only true right here. There are not two output values. There's only one output value. So is this a function? Yes, it is. Great job. Now let's look at problem 4. Determine if the graph represents a function and state the domain and range. We need to learn how to state the domain and range using interval notation and set builder notation. Let's do it. Is this a function? So you could draw your vertical line. There are no repeated x values. There are no double outputs. So is this a function? Yes. What is the domain and range? When we talk about domain, it's like driving our car along the x-axis. As I drive my car, I start all the way at negative infinity. Is this going to negative infinity? As you can see, this function keeps going, so it should have an arrow there that points us on forever. Notice the arrow takes me all the way back to negative infinity. So with interval notation, I'll start with negative infinity, always a parenthesis. And where do I stop? There's nothing else that the function exists that I can touch over here to the right. So I stop at 3. Notice it's filled in, so I need a bracket to represent that 3 is part of the function. What about the range? For the range, I'm taking the elevator up. Okay, so when I take this elevator up, where do I start? I start down here at negative infinity. And as I take the elevator, what floor do I start on? So notice I'm looking now at the y values. Bzz. I start right here, and this is a point on the graph, so I'd start at 0. So bracket 0 because it does exist at 0. And I keep taking my elevator up, 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 up. Now what's going to happen over here on the left is the function will continue to increase until it goes up, up, up to positive infinity. So this would be from 0 to infinity. Once again, a parenthesis on the infinities because you can't touch them, and so they're not included. They're just approaching the infinities. All right, how do we state that in set builder notation? Set builder notation, you would put a squiggly. This is the x values such that x is less than or equal to 3. What about the range? With my range, it's a y value such that y is greater than or equal to 0. Let's look at the circle. So is this a function? Boom. Vertical line test? No, it's not a function. No, not a function. What is the domain? So as I'm driving my car, I begin at -4. I drive that car from -4 all the way to +4. So the interval notation would be -4 to 4, both with brackets because they are part of the relation. Okay, now let's do the range. The range is take the elevator up. Now it's a huge squeegee going up. Where do I begin? So I see I begin at -6 and go all the way up to 6. Once again, brackets, because those 2 points do lie on the graph. How do I write that in set builder notation? So the domain is x, such that x is, how do I put between? So you'd put the x in the middle, and it would be greater than or equal to -4 and less than or equal to 4. What about the range? It's the same kind of idea. So the range is the y such that y is in between -6 and 6. So -6 would be less than or equal to y, which is less than or equal to 6. That is the domain and range of the circle. Let's look at the next graph. Is this a function? Vertical line test. Yes, this is a function. And drive your car for the domain. It starts at -2. So as I'm driving my car, I see that it starts at -2 and it is equal to that. So bracket -2. And then once again, this is going on forever and it goes up forever and to the right forever. So this would be -2 to infinity. Okay, so we can do the set builder notation. X such that x is greater than or equal to -2. Now let's take a look at the range. I'm taking the elevator from the bottom up, and it begins at -3, and it is part of the function, so it's a bracket. And I continue to go up. Don't get confused. I don't stop here because this side continues to go up. So I do go up to infinity. That could trick you, but don't let it. Okay, how do I depict that with set builder notation? This would be y such that y is greater than or equal to -3. All right, one more. I think you're getting the hang of this now. Is this a function? Yes, it is, because for every input, there's exactly one output, no repeated values. All right, what's the domain? So notice over here, this is going forever to the left, and this is going forever to the right. And so when I'm driving my car, it's -infinity all the way to infinity, both parentheses. And how do I do that in set builder notation? So this would be x such that x is in between -infinity and infinity. So we call this all real numbers. So you could put all reals, or you could put -infinity less than x less than infinity. Okay, and let's look now at the range. Now you take your elevator. So just go until that squeegee touches the water, which would be here. And that looks like the y value is 2, and it is filled in. So bracket 2. And notice that as you go up the elevator, those go forever to the left and right, and also forever up. So from 2 to infinity, and parenthesis, and the range would be in set builder notation, y such that y is greater than or equal to 2. Thank you so much. We'll see you next time.